Welcome to solving systems with non-matching coefficients using elimination. All right, this time our coefficients aren't as neat and tidy. I'm going to do number 16 and then I'll do number 13. So when I look at these, I've got a 5x and a 2x, and I've got a negative 7y and an 8y, and those distinctly do not match. I don't have the same coefficients and I don't have opposite coefficients. So I need to do something to get the same coefficients. So the first thing I'm going to do is I'm going to multiply. I'm going to focus on the x's. To get 5 and 2 to become the same thing, I'm going to multiply them times each other. So I'm going to multiply the top equation all by 2, and I'm going to multiply the bottom equation all by 5. It's similar to the process of getting common denominators. Okay, I'm going to end up with 10x minus 14y equals negative 32 when I double everything on that one. When I quintuple everything on this one, I'm going to end up with 10x plus 40y equals, well, 26 times 5 is going to be 130. Okay, now I can subtract my equations. All right, I'm going to subtract this way. I can go in either direction. Oops, let's undo that. I'll need those later, but not yet. All right, so I'm going to actually subtract 10x minus 14y equals negative 32 from 10x plus 40y equals 130. And when I do that, I will end up with nothing in the x term. 40y minus negative 14y is going to be 54y. And 130 minus negative 32 is going to be 162. Now, both of those are multiples of 9. That's something I noticed right off the bat, because 162 is 81 times 2, and 54 is one of the multiples of 9. But I'm going to go ahead and what I need to do is I need to divide both sides by 54. Okay, so I'm going to divide both sides by 54. Well, 50 times 3 would get me 150, so I think dividing 162 by 54 will probably get me 3. So I can test that out. 3 times 4 is 12, and 3 times 50 is 150. 150 plus 12 is 162. So I am left with an answer for y equals 3, because 162 divided by 54 is 3. Okay, now let's deal with these again. Now I could go ahead and plug 3 into everything, but I instead am going to work out a way to make the y coefficients the same. All right, to do that, I'm going to multiply the top by 8 and everything in the bottom by 7. So 8 times everything there and 7 times everything there. So 8 times 5x is going to be 40x. 8 times negative 7y is negative 56y. 8 times negative 16 is going to be twice 64, twice negative 64, so negative 128. And then I've got 7 times 2x is 14x. 7 times 8y is 56y. And 7 times 26, well, 7 times 6 is 42. And 7 times 20 is 140. 140 plus 42 is 182. All right, now I've got to decide whether I'm adding or subtracting. Since I have opposite coefficients, I'm going to add these. So I'm going to add these together. I'm going to end up with 54x here. 56y and negative 56y makes nothing. And then 182 plus negative 128 is the same as doing 182 minus 128. So 82 minus, okay, I'm going to borrow from the 8's column and make that a 12. 12 minus 8 is 4. And then this became a 7. 7 minus 2 is 5. Oh, look at that. And the 1 minus 1 is just 0. So that's very convenient. I'm going to divide both sides by 54. And x is going to equal 1. So my solution is 1, 3, since x is 3 and x is 1 and y is 3. Okay, if we have enough time to do this other one. If I don't, I'll make a part 2. Okay, so now we've got another situation where they are not, none of the coefficients match or are opposites. So I can't just simply add or subtract and eliminate something. And elimination is the name of the game, so let's come up with a way to do that. Again, I've got a 5 and a 2. I can make the 5 and 2 the same by multiplying each other by, make the top one by 2. Make it a coefficient of 10, and the bottom one times 5. Make that a coefficient of 10 as well. And I'll end up with 10x plus 6y equals 38. I end up with 10x minus 25y equals 55. So I'm going to go ahead and subtract these. 10x minus 10x is nothing. 6y minus negative 25y is going to be 31y. And 38 minus 55 is going to give me, well, if I reverse the subtraction, I'll end up with a negative, of course. So I reverse the subtraction. 5 minus 8, I've got to borrow. Makes the 50 a 40. Makes the 5 a 15. 15 minus 8 is 7. And 40 minus 30 is 1. So I've got 31y equals negative 17. I'm going to divide both sides by 31. And I'm going to end up with y equals an annoying number, negative 17 over 31. Now, this is definitely a case where I am not going to try to just plug that in because I can solve with using elimination again. Okay, so I'm going to use these same equations. I need to now make the 3y and the negative 5y either matching or opposites. If I multiply the top by 3, times by 5, it'll make a 15y. If I multiply the bottom by 3, that'll make a negative 15y. That'll work out for me. So I get 25x plus 15y equals 5 times 19 is going to be 95. And then that's going to be 6x minus 15y equals 33. And I've got to add them since I have opposite coefficients. So 25x plus 6x is 31x again. We got another 31. 15y plus negative 15y is 0. And then 95 plus 33 is going to be, well, 5 plus 3 is 8. And 9 plus 3 is 12, so 128. Definitely not a multiple of 31. So I'm now going to divide both sides by 31. Oops. And by 31. And x will equal 128 over 31, which you could simplify if you like.